Okay, let's continue with this session on chemical databases. So I'm just going to do a demo on how to engage with the PubChem. And once again, I'm just starting from the Google page and just typed PubChem, and I just click on that, get into the site. Okay. Um, so DNH, National Library of Medicine, PubChem. You can read more about the database here. And remember, you can also, like I said, in most of these databases, you can submit um, data that you have either for a compound that is existing there, or if you have a new compound that you want to submit, you can do that. Okay, so you can search for whatever you want, compound, small molecule. Well, they're not. I don't think they're limited to small molecules. There's uh, some other molecules, but not proteins that are not exactly very small, but they just call them small molecules. That you can use to that you can search for in this database. So look at it. Let me call your attention to this at the bottom. You can use words like COVID-19 is a disease, this current pandemic, to search for compound related to that. You can use the name of the compound. You can also use mm, the name of the protein, and you can use the formula of the compound. Um, I've not actually used this before. Then you can use the smiles. It's a format, digital format for compounds, and the INCHI key, which is another representation of compounds. Okay, I think I'll take a look at this later. All right, so let me, for example, let's try COVID-19. Just click on that. Okay, it's telling me there are 8,498 compounds related to that condition, and there are about 15 patents. 63 of them are substances, 645 are genes, proteins. Okay, so it does contain proteins, linked to others, linked to pathway, the bioassays, and of course, literature from which these things are emerged. Okay. Interestingly, chloroquine has been linked to COVID-19, so you can see that. Ritonavir, which is a compound, an antiviral compound, has been linked to that also. So it makes sense. Savipiravir, Savipiravir, I don't know, of course, azithromycin, an antibiotic. Yeah. So, all right. So one can search with the name. We can also search with the protein. Let me say, um, let me try the ACE that we used on the other side. Let's see what happens here. Okay, I didn't really see any compound related to this in terms of compound. Yeah, no, they are substances, not compound. All right. So I'm trying malaria pigment. Okay, so usually, I think that's just wanted to cross check that. Um, Usually for these chemical databases, you shouldn't be able to. Um, it's easier to actually use the name of the chemical rather than the disease state. Okay, perhaps because COVID-19 is it's a special case, that's why uh, they did that link here. Okay, but easy, like I said, it's easier to put the name of the compound um, that you want. The protein is also, and yeah, the other formats of the compound. But I want to also focus on um, one other way, which sometimes you might not know the name, but you just have an idea of the structure. And this, I want you to be able to do this. Um, so what I just did now, let me just repeat that. Step was to draw the structure. So I want to draw the structure. There's an icon here. You can click, takes you to an electronic chemical drawing page where you can draw a structure. So I'm just going to draw a random structure. In the hands-on exercise, I've given you 3 compounds that I want you to draw and search for. So we're going to draw an hypothetical compound here and search for that compound. Okay, so I just pick on this benzene ring and I put it on the board. I want it attached to uh, that ring, usually on that side. Okay, let me see. I can add a double bond here. Let me put it here. Let's see what happens. These other bonds are for stereoisomers, for compounds that have to depict chirality. I don't want to get too complex with it, but they are used to this, especially in sugar. There are compounds that have this what we call sterol chiral position, and you can use it to depict that. But let's just keep it simple for now. Let's keep it simple. Okay. You so this area is for putting they are pre what's it called now? Pre-designed structures that you can insert. We can also like just put that here. You can put that there. You can also put this here. Okay. Now the assumption is that for this each of this position have carbon in them. So usually it doesn't show the carbon um, in it doesn't really explicitly show the carbon. So each of these assumes their carbon, and at the end of each carbon is hydrogen. So those are not clearly shown sometimes, but you can change them if that is not the case in what you want. So, for example, if what I actually wanted I had an oxygen as here, I can insert the oxygen there. Just select what you want here. If it has, for example, chlorine here, you can do that. If it has, let me see if you can put a nitrogen in there on one of the rings. Yeah, there we go. What are interesting things that are here? I'm trying to find. Of course, based on the valency of that element that you're putting in there, we could also have another nitrogen there. If I put oxygen here, that's actually an OH that is here now. Okay, let me make it explicit. I can make it explicit by doing that, and just put the where's the hydrogen? There we go. At the end there. So there's an OH. I want to do the same thing here. So I'm going to do OH there. Because if you don't put an H here, it assumes there's a carbon here. So we need to explicitly put that there to replace the carbon that is assumed at that position. I'm going to make this, no, I want to make this a double bond. Okay, just get a carbon now into that position. Oh, carboxylic group into that position. All right, and you can delete them if you want to. You can just click on delete and you click on the atom you want to delete and you can get that out of that position. Okay, now that I have the structure, now you notice that the structure, once I finish drawing the structure, you will see the smile for that structure. So this is a digital representation of this particular structure. You'll see that. If you want, you can change to a smart representation. This is a smart representation of this structure. You can also see the standard, I call it, I really don't know the pronunciation, I call it inch key. And yeah, standard inch and standard inch key representation and formula representation also for that particular structure. Okay. And give me the molecular mass for that particular structure. Okay, cool. All right, so yeah. So you don't need to copy this if you want. Once you actually copy and go back and insert on that page, but you can search directly from this chemical drawing platform on PubChem. You can just search directly and it inserted the smiles there. Identity is 0 because it doesn't exist anyway. So I can imagine. All right. So let's do something that makes more sense. That will probably find in there. Okay, let's do that. Okay, let me see. And it's just another compound on the top of my head. Look at this one. Hopefully this will exist. Okay, there's a search for this. Oh, it still doesn't exist. Okay, so I will have to take an example from, let me take a simple example from the hands-on that I gave you. Okay, let me look for that. All right, cool, we could use that one. All right, so let me use something that's similar to that. But I'm sure by now you understand the concept of what we're saying. But just let me draw a compound that no, like that. So I can actually undo. I think I can undo. Yeah, I want to put that here. All right, cool. There's a chloroquine in which position here? No. There's a chlorine rather in that position. That's it. From the structure that I'm drawing. Take a look at it again. There's an N here. There's an image. Okay, cool. And then in here, and there's a link here. So another nitrogen. Okay. I'm gonna link that to this. Alright. Okay. I think I can stop here. Hopefully I'll have something similar to this. Let me just do the search. Yeah, we're able to get one compound. Okay, there we go. So my uncompleted attempt to draw one of the compounds actually coincide with a particular compound that is in the database. All right. So if I click on that, and which um, I want you to do for each of the compounds that I've drawn there, it takes you to the page for that compound, the compound summary. This is a summary chart. Gives you this PubChem ID, or what we call it CID. The structure of the compound. There's a 3D model also available um, for you to select different conformation, but let's leave that. It's a 2D representation, and a 3D representation, and formula, the synonyms in terms of the name. So you remember you have the full name here, the full scientific name, and the molecular weight. Okay. There's a 3D conformation, I think, that should appear here. Yeah, there we go. Of the compound. You can show in different representation, ball and stick representation. It can be in wireframe representation or space fill. Yeah, so that's the case maybe. You can download the structure from here, but let's not do that for now. Okay, so on this side of the site, you'll see related information to this particular compound. We have the structure, we have the name, an identifier, so it gives all that. So if you cool down the names and gives IUPAC name, the inch and the inch key, canonical smiles, molecular formula, yeah, synonyms, chemical and physical properties, computed properties in terms of, well, some of these properties were actually predicted from computer simulation. Hydrogen bond donor, hydrogen bond acceptor, molecular weights, log P, yeah, topological polar surface area, and the rest of them. And then some related records concerning this compound. Okay, there you see that because actually I was trying to draw chloroquine, but I didn't complete the structure. So yeah, you can see compounds that are related to that. Of course, chloroquine and hydroxychloroquine came up amongst the compounds that are related to that particular structure that I drew. Uh, Similar compounds also available, similar conformers available. You can see that. But for this compound, I'm not sure. Is there a patency? No patency. There is a patency for this. It's a patent for that. So that's the publication. Composition and methods for the treatment of cancer. So this compound was actually tried out in this study. Okay. Yeah. Cool. So I want you to actually, in your case, maybe complete that drawing and now get more information. You will have more information specifically towards bioactivity and the rest of it. Okay, for your compound. Um, yeah. So please take time to engage with that. I think there are three compounds that I want you to draw. We will send this to you, and then I want you to be able to answer some of these questions here. Um, there's some other activity related to another database that is very clear. You should be able to get that easily done also. But I just wanted you to explore some other databases. So that's why I inserted. I added another answer exercise that is on another database beyond PubChem. Okay, beautiful. So I'll be available for questions during your answer and to answer questions and to give insight as required. And of course, the tutor on ground will also take you through.